For centuries, Betelgeuse has glowed above humanity like a restless crimson beacon resting on the shoulder of Orion. Its deep red light, visible even without a telescope, has made it one of the most recognizable stars in the night sky. It has remained a constant presence for generations, inspiring myths, guiding travelers, and reminding countless civilizations that the heavens hold mysteries far beyond our reach. Ancient skywatchers carefully followed its subtle changes in brightness, recording its place among Orion's stars with remarkable attention. To some cultures it represented the shoulder of a legendary celestial hunter. To others it served as a seasonal guide, helping mark the passage of time, navigation routes, and the rhythm of changing seasons. Sailors crossed oceans beneath its glow, while travelers in vast deserts relied on its familiar red light to find their way across endless landscapes. Even in ancient times, observers realized that Betelgeuse behaved differently from most bright stars. Rather than shining with perfect consistency, its brightness slowly rose and fell in an irregular rhythm, almost as though the star possessed a heartbeat stretching across centuries. Though no one understood the reason, generation after generation noticed the pattern. Over time, Betelgeuse became more than a bright point in the sky. It symbolized the hidden instability that exists beneath apparent order, reminding humanity that even the heavens are constantly changing. Modern astronomy has revealed the astonishing reality concealed beneath that familiar crimson glow. Roughly 640 light-years from Earth, Betelgeuse is close enough, in astronomical terms, that the light reaching our eyes today began its journey while human civilization was still taking shape. Every photon arriving from the star is more than light, it is a message from the distant past. Looking into space is also looking backward through time. Although its surface temperature is significantly cooler than that of our Sun, measuring only about 3,500 Kelvin, Betelgeuse shines with extraordinary brilliance because of its incredible size. It is one of the largest red supergiants known. If placed at the center of our solar system, its enormous atmosphere would stretch beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars within its immense outer layers. It would completely reshape our understanding of what a star can be. Far from being calm, Betelgeuse is an unstable giant nearing the final chapter of its life. Its visible surface is constantly changing as colossal convection cells transport scorching plasma upward while cooler material sinks deep below. These turbulent regions are so enormous that entire planetary systems could fit inside a single one. The star appears to boil, shift, and reshape itself on a scale almost impossible to imagine. Beyond the visible surface, its atmosphere extends deep into space. Powerful stellar winds continuously push gas and dust away from the star, forming vast shells and expanding clouds that surround it like enormous cosmic veils. Betelgeuse is steadily shedding its own mass, releasing material forged deep within its core back into the galaxy. In many ways, the star is recycling itself. Carbon, oxygen, nitrogen, and other heavy elements created through nuclear fusion are carried outward by these stellar winds. Those same elements eventually become the raw ingredients for future stars, planets, oceans, and perhaps even life itself. Every cloud drifting away from Betelgeuse contributes to an endless cosmic cycle where dying stars help create entirely new worlds. But this dramatic process also reveals that the star is becoming increasingly unstable. Red supergiants exist in a delicate balance between the crushing force of gravity pulling inward and the tremendous pressure created by nuclear fusion pushing outward. As the star ages, that balance grows weaker. Eventually, gravity will gain the upper hand. Astronomers witnessed a remarkable reminder of this instability when Betelgeuse unexpectedly dimmed during late 2019 and early 2020. Its brightness dropped so dramatically that even casual observers could see the difference. Around the world, Telescopes turned toward Orion as scientists wondered whether they were witnessing the beginning of one of the most anticipated stellar explosions in modern astronomy. Speculation spread rapidly. Had Betelgeuse finally reached the moment when it would explode as a supernova? If so, it could briefly become one of the brightest objects in Earth's sky, potentially visible even during daylight and bright enough to cast faint shadows at night. As observations continued, however, the explanation became more fascinating than expected. The star itself had not dramatically faded. Instead, it had ejected an enormous cloud of gas that cooled into dust, temporarily blocking part of its light from Earth's perspective. Betelgeuse had effectively hidden behind material it had launched into space. Deep inside the star, nuclear fusion continues in layers. Hydrogen becomes helium, helium fuses into carbon, and increasingly heavier elements are created as temperatures rise toward the core. This sequence continues until iron begins to accumulate. Unlike lighter elements, iron cannot release energy through fusion. Instead, it consumes energy, removing the pressure that has supported the star for millions of years.